Topic 1.1.1, the purpose of the CPU. So the CPU performs the fetch, decode, execute cycle, which is where the CPU fetches instructions from main memory. So this could be an instruction to store an address into certain memory location, or to retrieve data from memory location 3, for example, or it could be to add a value to another value. So the CPU fetches the data from the main memory, it then decodes the instruction, where it takes the instruction and figures out, okay, what needs to be utilized to perform this instruction? Does it need to go to the ALU? Does it need to do this? And then the final stage, execute, is where the CPU actually performs the instruction. So let's say it's add 5 plus 3. It then will go to the ALU and perform that arithmetic operation. Okay, so we're going to take it to an exam question now. Identify 2 events that take place during the fetch execute cycle. And this is the exact mark scheme I've written out word for word, so remember this exactly. It says 2 events, but remember all of them. You don't know what angle this question is going to hit from in the paper. An instruction is fetched from main memory, so we've covered that. The instruction is then decoded. The decoded instruction is then executed so that the CPU performs continuously, so it goes decode, execute. The process is repeated. Remember, this is a cycle. It's the fetch execute cycle. This is how the CPU runs. It goes fetch, code, execute, fetch, code, execute. Okay, the program counter is incremented. We haven't covered the program counter yet, but we'll do that in the next video. Same with the MDR, memory data register, and MAR, memory address register. That will be covered in the next video. But for now, the program counter here is incremented. So if you look at this diagram I've made here, this is the program counter. It tracks where you are in the program. So let's say this program contains 4 bits in memory. This stuff here doesn't matter. But let's say the program counter is on 1. Program counter is incremented. It is now 2. So it's going from looking from 1 to looking at 2. The instruction is then transferred to the MDR. So you think, we run this instruction here, store. We're going to transfer this into the memory data register where it stores it so it can execute it. Okay, the address of the next instruction to be fetched is placed in the MAR. So basically, this 2 in the program counter is then copied into the MAR, 2, and that's when it then looks from 1 to 2. And it's okay, now we're going to load.